Welcome back. In this section we will learn how to use another microcontroller peripheral, the analog to digital converter. But first, we need to get a better understanding of what analog means and why it is fundamentally different from the digital logic and binary numbers that we have used earlier in this course. Recall, in the digital world, data only has two possible values, 0 or 1, yes or no, true or false. While this works well for the inputs and outputs we have used so far, we're about to find out it doesn't work well for everything, especially pizza. Here's the problem with binary pizza. Let's say I'm trying to determine if my pizza is cooked properly. The pizza on the left is not burned. It is totally frozen and not edible. The pizza on the right is burned to a crisp, and again, not edible. Imagine that we want to know more than if our pizza is simply burned or not. Specifically, we want to monitor the temperature of our oven to make sure that the pizza is cooked, but not cooked too much or cooked too fast. Our embedded system can use a temperature sensor to monitor the oven's temperature. And while there are many different types of temperature sensors out there, we're going to use a general example here. Our temperature sensor has an output that varies continuously with its ambient temperature. For example, the output of the temperature sensor might be 1 volt if the ambient temperature was 100 Celsius. Similarly, the output could be 3.5 volts when the temperature is 350 degrees Celsius. The output of the temperature sensor is analogous to the ambient temperature. Because of this analogy between the output voltage and the input ambient temperature, we call the continually varying temperature sensor's output voltage an analog quantity. This is relatively straightforward, but what happens when we want to cook the pizza at 225 degrees Celsius, almost 450 degrees Fahrenheit? Well, first we need to find the analog voltage that corresponds to 225 degrees Celsius. In this case, we can linearly interpolate the 225 degrees temperature to correspond to an analog sensor output voltage of 2.25 volts. Next, embedded systems will use a peripheral called an analog to digital converter that converts the analog input voltage, like 2.25 volts, into a binary number that can be processed by the microcontroller. Now, before we learn how the analog to digital converter works, we need a better understanding of analog circuits and analog voltages. The handout for this video will provide the necessary background to understand how the MSP430 microcontroller A-to-D converter works. Now, those that are already familiar with analog circuits can probably skip ahead to the next video where we show you how to write a program to use the FR6989 analog to digital converter. Now, this material can be a little tricky, so please let us know if you have any questions as you go. We are here to help.